Hi, everybody. It's Meteorologist Joe Cioffi. We are going to look at soundings. A number of you have asked me about soundings, what they are, and how do you read them. Well, a sounding is a snapshot of the picture of the atmosphere, but we are looking at the whole atmosphere for a specific point in time. And you're looking at it from the very bottom of the atmosphere where you're sitting to all the way up to 20, 30,000 feet. And you're taking a snapshot picture of temperature, dew point, and wind. And from that, you can figure out certain things, perhaps that are going to be vital to your particular forecast. So let me show you how to pull the sounding up, and then we will go and read it, and I'll show you how to read it. So I pulled up this map from tropicaltidbits.com, and you'll notice on this particular view, this is the GFS, by the way, and the soundings are available for some of the models, but not all, and for some of the geographic areas, but not all. So you just kind of have to play with it and to see which ones you can get soundings for. But you can get one for the GFS for this particular geographic zone. And I'm going to put, obviously this is a wintertime map, but we'll pull up a couple of different soundings so we can look at the profile of the atmosphere. First off, I'll pull up one in upstate New York. And here we have what it looks like on the graph. The map in the corner here, in the upper right corner, is the map we just pulled the sounding from, and it shows you where that point is. And across the top, it gives you the latitude and longitude of where you're getting the sounding from. The left side, these are the different pressure levels of the atmosphere, starting from the surface, going all the way up to 500 millibars, which is when we look at our jet stream maps, we use the 500 millibar map, and on it goes all the way up to 300, 200, and beyond. So the important thing is to look at the temperatures and the dew points. Those are really the two important things to look at here. And you'll notice that in upstate New York, you have a temperature of 19 and a dew point of 1. That tells you that you've got some fairly dry air at the bottom part of the atmosphere. The zero line, here's 0, so that's your freezing line. And it runs up on an angle as you head up higher and higher into the atmosphere. Accounting for the fact that normally you would see temperatures falling with height. Now, you can follow it along in terms of the sounding. You'll notice that temperature at the surface of 19 actually rises between 900 and 800 millibars, and then starts to slope back down, and it falls. In fact, if you look very closely at the outline of the red line, it sort of looks like a nose, a profile of a nose. So we often call this area that bulges down a warm nose. And in many situations, you'll see that warm nose break through the freezing line, and in a snow to sleet to rain situation, you'll see that warm nose breaking through the freezing line at higher levels of the atmosphere. So that's a good indicator. That's a solid indicator that it's telling you on the sounding that, hey, you've got this warm layer aloft, so your snow is going to change over to sleet or possibly to freezing rain. Notice the dew point here is even with the temperature. So near the ground, the bottom layer of the atmosphere from about just around 900 millibars down, there's a spread between the temperature and the dew point. So you've got dry air there, but then the temperature and the dew point run pretty even all the way up to 200 millibars. So it's telling you that the higher layers of the atmosphere are saturating. And given the map that we looked at, there was a storm headed for the Great Lakes with what appeared to be a giant warm front moving up the East Coast. That would make a lot of sense. The other thing you could look at the sounding for can be very important, wind, and it gives you the winds that it's forecasting, starting from the 1,000 millibar level and then going all the way up. And this could be particularly useful when you're forecasting thunderstorms. If you're looking at a sounding, for example, in a developing tropical system, you would probably look to see if you've got a wind shear going on, wind shear being hostile to development, and it would show up by showing light winds in the bottom part of the atmosphere, and then suddenly you have an area in the higher levels where the winds are increasing. And then for those of you who are into thunderstorm development, you can actually derive the sounding derives different types of values. These are highly technical, so I usually don't refer to them very often, if at all, when I'm doing my live streams. But if you're interested in looking at things like the CAPE, for example, which is it helps you. The CAPE number tells you basically how unstable the atmosphere is. You'll see some of these values show up here on the side. But really the important takeaway for basic forecast use, especially in the wintertime, is you're going to use it for this idea of a warm nose. If you move down to take a look at a sounding, for example, say here in the southeast, where we've got a warm sector to deal with, you'll notice a different profile different atmosphere look. And the temperature is 70. The dew point is in the mid 60s, 66. And look at that's saturated all the way up to 200 millibars. So this probably an indicator that there might be some thunderstorms on the way later on in the day. The winds, notice the winds at the surface from the southwest, but they quickly pick up in the levels as you go up to about 900, 800, and all the way up. You're talking 50 knots or more. So this certainly seems to be ripe for some thunderstorm activity. If you look at the map above in the upper corner from where we pulled the point, you do see that the GFS does have some rather active weather forecast for the area from western Tennessee down into northern Alabama and northwestern Mississippi. So you could certainly argue from a sounding like this that there probably will be some convective weather to deal with later on in the forecast period. So that pretty much covers the most important basics with regards to the sounding. You're taking a snapshot of the atmosphere. You're looking at it from the bottom up. It's kind of like you're looking at it straight, and you're seeing all the levels of the atmosphere in front of you. And very useful especially in the wintertime when you're trying to determine rain snow lines, where that warm layer is somewhere between, say, the bottom of the atmosphere and then going up to about 7,000 feet or 10,000 feet. You kind of look for where that warm nose is sticking its nose through the 32-degree mark, through the freezing line, and giving you precipitation type headaches in coming up with your forecast. So that wraps it up with the sounding. If you've got any other additional questions about them, just leave them in the comments section and I will gladly answer them. And be sure to tune into my YouTube channel on a daily basis for my daily live stream, which is usually at 7 o'clock Eastern time.